Okay, welcome back. Part 2. So again, we're going to evaluate infinite geometric sums. And we have a formula that will work for us. Or you can use the trick that we just learned. But I found most students prefer to use the formula. And we'll work another one using the sort of Gauss trick. But let's see what we get for this one using this term. So first of all, this formula. What is the key? So you look at this, and I think it should be fairly obvious that what we're doing to get the next term, we multiply the previous term by 1/4. We start with 1/4, and then we have 1/4 times 1/4, and then multiply again and again. So this is a geometric sum, and the key is 1/4, and it is infinite. We need that, or this formula doesn't work. So what is my first term? It's 1/4, right? There's my first term, divided by 1 minus 1/4. So this is 1/4 in the numerator. And what is 1 minus 1/4? Well, this is 3/4, right? The way I see this is like if you have a whole thing, you divide it up in 4 pieces, you take away one of those pieces, you're left with 3/4 of them. If you want to do this more formally, if you can't do that in your head, what we're doing is getting a common denominator. And it's easy for the number 1. You can write the number 1 as any fraction you want. It just has to be same in the numerator and the denominator. So this is the same thing as the number 1, and then you remember how to subtract fractions. So we get 3/4. And now you have to remember what to do with this kind of complicated fraction. Well, um, my students have taught me a trick. They call it keep, change, flip. And what does this mean? We keep the numerator. We're going to change the operation, and we're going to flip the denominator. So let's see how this works out. This would be keep the numerator, change the operation. What is the operation? The operation is divides. We change that to multiply. And then we flip the denominator. So what does that equal? Well, you might multiply it out and get 4/12, and then you reduce that. It's 1/3. So this sum is 1/4 plus 1/8 plus 4 to the third power is what? No, 1/4 plus 1/16 plus 1. I have to do that with my calculator. I'm going blank. Yeah, I thought it was 1/64. It starts at 1/4, but the total, which is what we're after, is 1/3. Kind of surprising. So here's another one. First thing you want to do is check. Is it infinite? Yes. Is it a geometric sum? Well, if it is, then there's this key number that we multiply by, and I see that it's 1/3. So how do I solve this? Well, the total is going to be the first term divided by 1 minus the key. So let's see what we get. What's the first term? that first number right there. 1/3 divided by 1 minus 1/3, which will be 1/3 over 2/3. How did I do that? Again, 1 minus 1/3 is the same thing as 3/3 minus 1/3, which is 2/3. Now I can keep the numerator, change the operation, flip the denominator, and see that I get 3 over 6, which equals 1/2. So that is the sum of this geometric series. Now this one is a little different. But is it infinite? Yes. Is it geometric? Maybe you're not sure. Well, I started with the number 2, and then how did I get the next term? I multiplied the number 2 by 1/3, and then I did that again to get 2 times 1/3 squared, and again. So yes, this is a geometric sum, and the key, what is it? It's 1/3. However, the first term is different. So what do we want? We want the first term divided by 1 minus the key. So what is my first term? That's the number 2. What is 1 minus the key is 1/3. So this is 2 divided by 2/3. So again, we keep the numerator, we change the operation, flip the denominator, and this time, what is 2 times 3/2? Well, you can always turn 2 into a fraction if you want, and then you see that it's 6 over 2, which is 3. So this sum is 3. Now, I'd like to look for ways to convince myself that the answer is correct. Now, so let's look at this sum. The previous sum that we did over here, that added up to 1/2. So how can I relate that to this? Well, this is like 2 plus 2 times that previous sum, isn't it? Because here's the previous sum, and everything is multiplied by 2, and then I added 2 to that. So that would have been 2 plus 2 times that previous sum, which was 1/2. 2 plus 1 equals 3. So that's kind of neat. Sometimes you can see connections like that and convince yourself, yeah, that is the correct answer. So you will have to do these kinds of geometric sums, like A, B, and C. So make sure that you can do these. Practice them on your own. And I give you on the handout some additional problems with solutions so you can practice them. And this is a very important problem. This will be on exam 2. This will be on the final. So it's important that you learn how to do this. Okay, first we have to understand the problem. Let's read it. A pendulum. You know, those pendulums, you pull it back and then it starts going. And then it'll go back, right? So it swings through an arc of 30 meters. So on its first trip, it went 30 meters. On each subsequent swing, what is a subsequent swing? That just means next, doesn't it? On each of the following swings, it travels through an arc 2/7 as long as the previous swing. Okay, so it went 30 meters on the first swing. On the second swing, it didn't go 30 meters, it goes 30 meters times 2/7. That's how far it traveled. That's 2/7 as long, 2/7 times 30 meters. All right, what happens on the third swing? It goes, well, this distance times 2/7 again. It goes 2/7 this distance. And then on the fourth swing, it would go this distance times another 2/7. So that's 30 times 2/7 times 2/7 times 2/7, which usually we would just write this as 30 times 2/7 cubed. Okay, so this is just trying to get to understand the problem. This is what's happening. Now, what is being asked of us? How far does it travel if it never stops? Well, I'm going to tell you something right now. Not infinity. It does not travel an infinite distance, which seems like a contradiction because it never stops and yet it doesn't go to infinity. So let's see what's going on. We're going to try to make a formula. So what we have from before, we'll call this D for distance. It first goes 30 meters. Then it goes 30 meters times 2/7. The next swing, the third swing, is 30 meters times 2/7 squared. The next swing is 30 meters times 2/7 cubed. Then it's going to be 30 times 2/7 to the fourth power, and this keeps going forever. Never stops. This is an infinite sum. Is it geometric? What do you think? If it's geometric, we get the next term by multiplying the previous term by the same key number. So I say yes, and the key is 2/7. So now do you see what we're going to do? We have a formula. This total will be the first term divided by 1 minus the key. So let's see what we get. What is the first term? That's 30. 1 minus 2/7. Okay, we can do that. That will be 30 over what? 1 minus 2/7 is 5/7. And now we just need to do our keep, change, flip, and figure out what that is. What is 30 times 7/5? Now, you can do it many different ways. What I would do, I see I have 30 times 7 over 5. We can do this. And then I like to simplify this piece right there. What's 30 divided by 5? Isn't that just 6 times 7? Which is what? This is 42 meters. Now, if you had multiplied it out another way, you would have gotten 210 divided by 5, and you can put that in your calculator, and you would get the same answer. So this is an important one to know how to do. The one in the homework is very similar, but it might not be 2/7 or it might not be 30 meters. So just make sure you identify the first term and the key and use this formula, and you should be good. Now these last 2 pages are just extra for you to practice, and you have the answers over here. Here's another. This is the pendulum problem that we just worked, done in detail for you. So you are ready to do the homework now on Canvas, and let me know if you have any questions.